When we return to the detection table, we can see a WMI incoming lateral movement alert next in the list. It seems the attacker wants to laterally move across the environment using a newly minted SQL Service user. When we click on the link, we can see a description of the rule, its alignment to the MITRE ATT&CK framework, and also the search query that's used to detect the event in Elastic. At the bottom, we can see our alert, but I'd like to see the events leading up to it, as it detects a sequence. By clicking Including Building Block Alerts, we can identify that the Windows 10 host we filtered for earlier, ending in .105, is talking to the SQL host ending in .104. If we look at the process event in the analyzer, we can see that PowerShell.exe is the process doing the communication. When we drill in a bit further to look at the PowerShell.exe process, we can see that it is being run by the SQL Service user. Based on this, it appears the mechanism used here to exploit the Windows Management Instrumentation Command Line Utility, or WMIC for short, is used to deploy the new C2 or Command and Control agent via PowerShell. Let's update the case with what we know so far. There must be communication back to the Command and Control server somewhere, likely via HTTP, but we need to verify that hypothesis. So while we complete our comments, let's go and find out and build a new timeline to test this. As we know, the PowerShell.exe process was run by the attacker's credentials, SQL Service. Let's start by adding that to the timeline. We also know that suspicious behavior was observed on the SQL host, so let's add that into the query builder too. It looks like there is a lot of communication to a local IP ending in .107, but it's not one we recognize. Let's investigate what these connections are by looking at one of the connection events. We can see that it's PowerShell again and that it's communicating with this host. If we take a look at the network events for PowerShell, we can see it communicating to that suspicious host 192.168.20.107 using port 80, HTTP traffic as we suspected. To further prove whether all of the events in the timeline are communicating in the same way, we can go back to the timeline and add the destination.port as a new column to the table. That way we'll be able to see what port number is being used for all of these particular events. Looking at the events, it does seem that port 80 is being used for all of them. The final step is to confirm what else has been communicating with that .107 host seen earlier. So let's use the network context view to find out more. Here in the source IP section, we can see the two servers from before, the Windows 10 host on .105 and the SQL host on .104. It looks like all the hosts we've been investigating so far are communicating back to this host, so let's add this information to the case. We'll go back to the timeline and rename it to do with our SQL Service user activity. And then add this to our existing case from earlier. We'll add a comment that all the hosts are communicating to this .107 server where the protocol is HTTP, suspecting this might be the command and control server we're looking for. Fortunately, we didn't have a rule in place to detect traffic over HTTP where PowerShell is being used. However, we can quickly build one. If we navigate to Discover in Kibana, we can build this rule. We'll do this by using process.name is PowerShell.exe and the network protocol as HTTP. In order to prove this is correct, let's add host.hostname, source.ip and destination IP to validate the same information. This looks good, so we'll save the query and use it later to create a detection rule. Given we now have confidence that the communication is to a command and control server and it's over HTTP, we can find out what the agent is actually called, and we can do this in Lens. Lens is Elastic's drag and drop visualization builder, so let's see if we can quickly find out what we're after. Let's drag process.name in from the left into the main stage. This will show us the total number of records by the process name. We now want to filter these results to the destination of that .107 server, which we can type in the filter bar at the top. And then we want to break down this graph by the protocol so we can confirm what we've just seen in Discover. This gives us proof that the Office Updater process is sending a lot of requests via HTTP to that suspicious host .107 that we do not have control over and are highly suspicious of. Now we have identified the command and control behavior, let's go back to the detections page and see what the attacker's next steps were.